Everybody, this is Miss Piekarski, and I am going over the test review for our sequences and series test that will be on Wednesday. Let's go ahead and get started with the very first question. And I have the scenario of Mrs. Piekarski Brigg made a pattern with a box of toothpicks as shown. The number of toothpicks used for each phase of the pattern creates a sequence. And the first question about this scenario is list the first 5 terms of the sequence. Okay, so if each of these lines were toothpicks, then there would be 1, 2, 3, 4, 5, 6, 7, 8 toothpicks in the first diagram, or I don't know, what do they call it, the pattern. And then for the second pattern, you'd still have the initial 8, but then you'd have 9, 10, 11, 12, 13, 14, 15. And then for the third pattern, you'd have the 15 plus the 16, 17, 18, 19, 20, 21, 22. So the first 3 terms would be 8, 15, and 22. If you look at your answer choices, choice C is the only one that gives you those first 3 choices. So in this case, the answer would be C, 8, 15, 22. And hopefully by this point you figured out that your first term is 8 and you're increasing by 7 each time. So 22 plus 7 gives you 29, and 29 plus 7 gives you 36. Okay, so that's how we got that one. Let's look at the next question. Again, same scenario with the toothpicks, but this time the question is this sequence arithmetic, geometric, or neither? Well, because we are adding by 7 each time, then the correct choice would be an arithmetic sequence. And then question 3, same scenario, express a sub n, the number of toothpicks used for the nth set of houses recursively. So this time you just need to remember how to set up the recursive formula. And we already talked about our first phase of the pattern here had 8 toothpicks in it. So our a sub 1 should be 8, which is right here. And I don't think there's any other ones where a sub 1 is 8, but we'll check and make sure that we add by 7 each time. So the previous term plus 7, so this would be the correct answer for the recursive formula. And then question 4, again, same scenario. And we just need to express a sub n, the number of toothpicks used for the nth set of, I think that's a typo, the nth set of objects, I don't know what you would call those shapes, explicitly. Anyway, so we need an explicit formula. Well, this time, notice that my answer choices are not in the standard explicit formula that we're used to. These are simplified this is a simplified pattern. Okay, so we need to first set up our equation. So it would be a sub n equals, our first term was 8, plus the common ratio of 7. That's a plus sign, guys. Sorry. And then times n minus 1. Okay. Once we distribute the 7 throughout the parentheses, this ends up with 7n minus 7. You need to distribute this 7 to the n and the negative 1. So we end up with a 7n, and 8 minus 7 gives us a positive 1. So here, our answer choice would be option D. Okay, so this is our explicit formula that has been simplified here. All right, moving on. Again, exact same scenario. Question 5, suppose this pattern were continued, how many toothpicks would be in the 10th set of the phase of the pattern? Okay, so to do that, we need to plug in the equation, and we could use either our explicit formula that's been simplified, like this one, or we can use our explicit formula that hasn't been simplified, or if we really, really wanted to, we could use the recursive formula. The recursive formula would take a long time. I would suggest, that we use this equation here, 7n plus 1. And so we want when a sub n, or so we want a sub 10, excuse me. And so a sub 10 would equal 7 times n. Well, if n is 10, then I'm going to write 10 here, and then plus 1. Okay, so 7 times 10 is 70, plus 1 gives me 71. So this is the correct answer choice here. All right, so this should be the very last problem with this same scenario with the patterns. So after Brig created the 20th phase of the pattern, his older sister Johanna knocked all the toothpicks on the floor. How many toothpicks did the kids have to pick up? Okay, so with this one, we can either use our series formula or we can use our sigma notation. If we use the series formula, it would look like this. S sub n equals not S sub n, S sub 20, since we're looking for the first 20 terms. So it would be 20 divided by 2. And then times our first term, which was 8, plus our last term. And to get our last term, we have to figure out what a sub 20 is. Okay, and we can plug it into our explicit formula, one that's already been reduced for us. So it'd be 7 times 20, and then that's supposed to be a parenthesis, sorry about that, and then plus 1. Okay, so 7 times 20 is 140, plus 1 is 141, so I'd have 8 plus 141. Okay, and then, well, 8 plus 141 is 149, and then 20 divided by 2 is 10, so it'd be 10 times 149, which is 1,490. So with the series formula, we got 1,490. If we wanted to put it in sigma notation, we could, and it would look exactly like this. The n equals 1 would be down here, 20 would be up here, 8, this would be our sequence formula, the 8 plus 7n minus 1 in simplified form. If we didn't put it in the if we didn't put it in the original form, if we kept it the simplified form, the 7n plus 1, we would still get 1,490. So the calculator doesn't care if we simplify the equation as long as we have everything else set up correctly in the calculator. All right, so let's look at some different problems on the test. You're going to notice that in this case, the first 6 problems all have to do with the exact same scenario. All right, so now let's look at a new one. A new employee earns $62,000 during his first year of work and receives a 12% raise each year. Which of the following sigma notations could be used to determine the total amount earned by the employee over 20 years of employment? Okay, so again, we just need to figure out how to do sigma notation. So our first term would be the 62,000. So we need to find all the cases where the sigma notation uses the 62,000. So those are 2 cases. This is not right because it uses 38,000. I don't know where that came from. So automatically we were able to discount or cross off 2 of our answer choices. So let's look at the other answer choices. Here we have the 20 up here, which comes from the 20 years of employment. And then we have 1.12. And some of you might be thinking, hey, 12% is 0.12. Why do we have the 1 there? And the reason why we have the 1 there is we don't want to know how much of a raise he's getting. If we just multiply by the 12% like these 2 are doing here, then we won't know what the total amount of money that he's getting paid for the year will be. We'll only know how much of a raise he'll get, and we want the total amount. So that's why we need the 1.12 here, the 12% plus the 1 whole. So if you look at these 2 options, they look exactly the same. But right here, our exponents are what are different, okay? So this one is just n, and this one's n minus 1. Well, if you remember what the formula is, you'll know that the correct answer choice is B, the n minus 1, not this one, okay? Now, I believe we have the same scenario in like 2 more problems. So the exact same scenario. Which of the following series formula could be used to determine the total amount earned by the employee over 20 years of employment? Okay, so this time instead of the sigma notation, we need to figure out what the series formula would look like. And again, we need 62,000, and it looks like all 4 of these have 62,000, and we need to have a 20 years of employment. So my n value would be 20, okay? And notice there's just some slight differences here. Let me take that off. First of all, this one is inside of the parentheses, and we're just raising our rate by 20%. This one's outside of the parentheses, and we're raising this whole thing by 20% to the 20th power. So that is incorrect there. Again, this one is, the 20 is outside of the parentheses, so it's 1 minus this raised to the 20th power, so that can be crossed off there. So again, we've discounted or crossed off 2 of our options, so we need the option where the 20, the number of years we're adding all together, is inside of the parentheses, okay? And hopefully you guys have realized that this is a geometric series. Okay, it's a geometric sequence because we're multiplying by 12% each year. Actually, we're multiplying by 112%, sorry, excuse me. And so that's why it's a 1.12 versus just the 0.12 here. So the correct answer choice is D. That's the only one that has all of the numbers exactly where they need to be. All right, moving on. Again, exact same scenario. And we need to know what is the total amount earned by the employee over 20 years of employment. Well, hopefully, some of these answer choices can automatically be crossed off. Like the $19,000, he makes more than that in 1 year. So we know that's not an option. And $65,000, he makes a little bit less than that in a year, but he's definitely going to be making more than that in 20 years. So now we're down to option B and option D. We have to do our math to check it out. And we can use either sigma notation or we can use the series formula. It doesn't matter which one as long as we pick the correct one. And on here, I'm going to go ahead and show you guys how to set up the sigma notation. So remember, to find the sigma button, you click on the button next to the 9, and it's right there. And then we have n equals 1 down here. We have 20 up here. And because of the 20 years of 20 years of what? 20 years of working at the same company. Let me look at this, okay? And let me see, his first pay is A sub 1, his first term was 62,000. So it would be 62,000 times the 1.12, and that is raised to the power of, and I know lots of you love to put a 20 here, minus 1 because that's our n value. When you do that, you get this weird answer that doesn't make a whole lot of sense. You know, yeah, maybe he might possibly get $10 million in 20 years, but I don't think so. And it's not one of our answer choices. So guys, if you do something like this and you're not getting the right answer first, check and make sure you've set everything up correctly. I don't want that anymore. That's the wrong answer. Okay. So let's go back to here. Hopefully you guys have spotted that I put 20 here instead of an N, and it needs to be an N, and I push enter, whoops, and I get this weird number. Well, what the heck does that weird number mean? If you highlight it and push enter, you can see that it's, let's see, 1, 2, 3, 4, 5, 6. So 4,467,251 and 43 cents. And that is the answer choice that we have there. All right, moving on. Another scenario, we have Archimedes uses a pattern of squares as shown. What is the common ratio for this pattern? Okay, so we have a square, and then we have a much smaller square, and it might be difficult to figure out what the common ratio is, or what portion of the larger square the smaller square is multiplied by. So I'm going to show you how we are going to figure that out. And guys, on the test, please don't write on it. We're going to pretend that our image is perfectly square, but it probably isn't. All right, so there's one square. And instead of making another one, I'm just going to move this over. And I'm going to copy and paste, or I'm going to duplicate it. So that's another one, okay? And so that you guys can see, and let's pretend that this diagram is to scale and everything, that we have 1, 2, 3, 4. So we've cut that big square into 4 smaller squares, and which means that whoops, that's not what I wanted to pick. Excuse me, there we go. Move that, and let's move that. That means that this square here, the second term in the pattern, is 1/4 the size of the big square here. Okay, so that means our common ratio is 1/4. Okay, now I will tell you, you're not going to have this question on the test, but I included it in the review because I wanted to show you how we got that common ratio. The question that you're going to have on the test looks like this. So you have the exact same picture, but they're asking you what would be the sum of the areas of these squares if the area of the largest square were 13 centimeters squared. Okay, so now we know that our common ratio is 1/4 because I just demonstrated it to you. And I need to add together all of the squares in the picture. I don't have to guess how many squares there are. And if you look at this word, infinity, assume the pattern continues to infinity. I don't know if it does or not, but no matter what, that word should be like a red flag saying, hey, this is an infinite geometric series, and if we remember that infinite geometric series has to have a ratio less than 1, then we will hopefully remember how to use our infinite geometric series formula, which is we have to take our first term, which in this case is 13, and divide it by 1 minus our ratio, which in this case is 1/4, or 0.25. I don't care which way you do it. And let's plug that into the calculator. I'm going to clear this mess because I don't need to see it anymore. So that would be 13, which is our initial squares area, divided by, and this I'm going to put in parentheses, 1 minus 0.25, or 1/4. And then I'm going to close parentheses, and I'll show you why I put it in parentheses in a second. Okay, so notice because I put it in the parentheses, everything's in the denominator. If I didn't do the parentheses, if I just did 13 divided by 1 and the minus 0.25, let me show you what it looks like. It looks like this. Notice that the minus 0.25 is over on the side, and also notice that the answers are very different from each other. Okay, so in this case, my answer was 13.33333. And let's go ahead and look at our answer choices. Or I said 13.33333, didn't I? 17. I had 3's on the brain for some reason. It's 17.33333. If you already know that 0.333 is 1/3. So our correct answer was 17 1/3 cubic centimeters. Centimeters squared. Centimeters squared. All right, next question. Which of the following sequences will converge? All right, so hopefully you guys remember that converge means it's all going together to one location or one number. Okay, and let's look at our options here. We have this one where it looks like, let me see, if we think we're subtracting by some number each time, let's see, what would it be? So 75 minus 45 would be what, 30? Well, 45 minus 30 is not going to give us 27, so we're not subtracting by the same number each time. So let's see if we have a common ratio right here. So 45 over 75. Okay, I'm taking two terms to see what the common ratio would be. And I am not doing that in my head, so let me use the calculator. 45 divided by 75 gives me 3 over 5. Let me make sure that's consistent. So let's do 27 over 45. So 27 divided by 45. And again, it gives me 1/3. So this one has a common ratio that's 3 over 5. Okay, so that equals 3 over 5, and that's our common ratio since it's geometric. And I know that this one will converge. Let's look at the other ones and see if they'll converge. It looks like, let me see, if I was going to add by the same number each time, I doubt I would have all these decimals. So let me see if this one has a common ratio as well. So that's 11.664. And then divided by 9.72. 9.72. And it looks like I'm multiplying by 1.2 every single time. Let's see if that's consistent. Let's do 11.664 times 1.2. So 1.2 times 11.664 and see if we get our third term, 13.9968. 13.9968. So it looks like this one. So this one has a common ratio of 3 over 5, and this one also has a common ratio, but it's 1.2. I'm multiplying by 1.2 every single time. Now let's look at this one. It looks like, just from looking at it, it looks like I'm subtracting by 6 each time. So 75 minus 69 is -6 or -6. 69 minus 6 would give me 63. 63 minus 6. So this one has, for C, it's a common difference. And I'm just subtracting by 6. And if I keep on going with this one, it will give me negative numbers eventually. Now, if I look at this one, it looks like I'm adding by the same number each time. Let me see. It looks like I'm adding by 7. A plus 7 here. Let's see if I'm adding by 7 here. 25 plus 7 does give me 32. 32 plus 7, it gives me 39. So we're adding by 7 each time. So this one has a common difference. And so both, you're never going to get a convergent sequence that is arithmetic. And both of these are arithmetic. So neither of those will converge. This one, it is geometric, but the number is greater than 1.2, so it's not going to converge. It's going to keep on getting bigger and bigger and bigger. So this one is not converging either. So my only answer choice, or the only correct one that is converging, is option A, because my ratio is less than 1. Let's see, given the arithmetic sequence, 75, 69, 63, 57, 51, and 45, right? An expression for a sub n recursively. Okay, so again, this looks like it's my first term is a sub 1, and it's recursive, so I have to list a sub 1 equals 75. And these are not recursive because it does not say a sub 1 equals 75. So I need to see this in order for it to be recursive. Okay, and then it looks like I have an arithmetic pattern. And so I'm going to have a common difference of 6. Nope, I'm subtracting by 6 each time, so -6. Okay, well, this is a geometric, so that's wrong. This one does have me subtracting the previous term, or taking the previous term and subtracting by 6, so the answer B is the correct option. Let's see, 14, given the arithmetic sequence, write an expression for a sub n explicitly. So different pattern, and I just need to write it explicitly. So I have 18, 25. Oh, that's not what I want. I am adding 7 each time. Yep. And then, so they want an explicit formula. So I'm not going to list my a sub 1 separately. So it's not going to be these two. And I am going to have an 18, but this says it's an arithmetic, and it is adding by the same each time. So this is a geometric sequence. So the only answer choice is D, and they didn't even simplify the equation. So that should be pretty easy to spot. Let's look at the next one. Given the geometric sequence 75, 45, 27, 16.2, and so on, write the expression for a sub n recursively. Okay, so I'm just switching back and forth between recursive and explicit. Because it says recursive, I need to see my a sub 1. Those are not recursive. And this one, it's a geometric sequence. And so this one is an arithmetic sequence, so I'll automatically know that this is the only correct choice. I haven't even checked to see what my common ratio is. I suppose I could, but I really don't need to because I know that's the only one that's in the recursive geometric pattern. Okay. Last question. Given the geometric sequences like that, write an expression for a sub n explicitly. All right, so again, let's see if we can do this without even bothering trying to figure out what our common ratio is. So it needs to be explicit, so it's not these two since these have a sub 1 equals some number, so that's our recursive formula. And it's a geometric sequence, so it cannot be deep because this is an arithmetic. And so my only answer choice that's left is C. All right, so hopefully this review has helped you. The test will be on Wednesday, and I will see you tomorrow. Bye.